So product and quotient rule are other methods of differentiation, just like we have chain rule and we have first principle. So let's might have y equals to u times v, where u and v are functions. So u is a function and v is other function. Where am I doing the two functions? I'm multiplying the two functions. So how do we find dy dx in this case? How do we differentiate this expression? Whenever we are multiplying two different functions, we say this is a formula which is called the product rule, which is u dv dx plus v du dx. So this is the product rule. Again, let's say I have y equals to u over v. In this case now, I'm dividing two different functions. So dy dx will be equals to a v du dx minus u dv dx L over v square. Okay, so this here is called the quotient rule. But let's take a little example. Let's say I have y equals to x squared sine x, x squared sine x. Now looking at this now, there are two different functions here. X squared is an algebraic function. This is a function. And sine x is a different function, which is what? A trig function. So look as if I'm multiplying this function and this function. There's a times between them. This is what this is product rule. So you can say let u be x squared and v be sine x. So differentiating u in respect to x, I will have du dx. That should give me 2x. And differentiating v in respect to x, I will have cos x. Because when you differentiate sine x, you get cos x. So since this is product rule, I can use the formula of product rule that says dy dx is u dv dx, that's u times dv dx plus v times du dx. So dy dx will be equal to, what is u? U is x squared, right? U is x squared times, what is dv dx? dv dx is cos x. Okay? Plus, what is v? V is sine x. I'm only substituting what I have here for my product formula. So v is sine x times du dx. Du dx is 2x. Where this give me dy dx will be equals to x squared cos x plus 2x sine x. Let's take a look at this. Let's say y is equals to tan x. Y is equals to tan x, and it has to find dy dx. Recall that dy dx of tan x on the previous video, dy dx of tan x is sec square x. So 7 for this now, we have y equals to tan x, and don't forget that tan x is equals to sine x over cos x. This will give me y equals to sine x over what? Cos x. So looking at this very well, you can see that this is a quotient rule. Having a function of, I've divided two different functions. Let me come back to this. We're dividing two different functions, okay? So you can say let u be sine x, since it's on top, and let v be right now be cos x. So differentiating u in respect to x, what we get? We get cos x, and differentiating v in respect to x, what do we get? We get minus sine x. So we call the formula for quotient. We know that dy dx is equals to v du dx minus u dv dx n over v square. So solving for this, our dy dx will be equals to, what is my v? My v is cos x, right? So cos x times, what is my du dx? Du dx is also cos x, all right? Minus, what is my u? My u is sine x times, what is my dv dx? My dv dx is minus sine x n over v square. And what is v? V is cos x, so v square will be cos square x. So from here, you can say that dy dx is equal to, multiply this, what do you have? You have cos square x minus, okay, minus and has to give me plus, this become plus sine square x all over cos square x. Now recall recall from trigonometry functions that cos square x plus sine square x is equal to 1. So if you put it here now, this will become 1 over cos square x. Alright, so dy dx is equal to 1 over cos square x. Now also recall from trigonometry ratios, inverse properties, that 1 over cos x is equal to sec x. 1 over sine x is equal to cosec x. And 1 over tan x is equal to cot x. Remember, this is, if you look at sec x, if you count the letters, this is 1, 2, 3. Next the third letter. It is the same thing here. 1, 2, 3. Sorry. Note the third letter, that's S. Let me change the color for that. And note the letter here as well. 1, 2, 3. That's T. That's tan. So if you look at it, you can see T, 1 over tan, S, 1 over sine, C, 1 over cos. That's very good to remember. So going back to our question, we have 1 over cos square x, and 1 over cos x is sec x. Then 1 over cos square x should be what? Will be sec square x. So this proves that if y is tan x, dy dx is sec square x.